Okay, let's see. Let me move a little closer so I can see the screen very quickly. Okay. Alright, hi guys. So this live stream is gonna focus on my, I want to say, mostly my skills in geometry, or how good I am at geometry. I feel like, I don't know, there are things in geometry, and the reason why I haven't made geometry videos, or a lot of geometry videos, is because geometry is one of those subjects that it can be very difficult sometimes for me, and that is because geometry is very, I want to say it's very analytic, and it's very different from the other classes that, or at least to me, it's different from algebra and trigonometry. Even though trigonometry is part of geometry, it's the reason why it can get very difficult is because it's just really, it has a lot to do with theorems and definition. And the thing is that, you know, especially for me, like, because it has a lot to do with theorems, excuse me, and definition, it's, how do I say it? Like, it's just really, it can get very tricky. It can get very tricky, and it can get very difficult, especially if we don't know what the theorems are. And the thing is that, well, yeah, because of that, that's kind of why the class itself is very tricky. Now, one of the things that I do want to do in this video is I just want to show you guys exactly what I can and cannot do in geometry. Okay, and I will use Khan Academy for this. And maybe I can turn down the volume. So let me and so that way it doesn't play the sound whenever I use it. But yeah, the main thing is that, so I'm first gonna get ready for geometry. Now this is just a little like preparation for geometry, right? And actually, and I don't know how long this is gonna be. I don't know how long this live stream is gonna be. I'm just gonna try to do as much as I can of this stuff, you know. So I'm gonna do a little course challenge for Get Ready for Geometry, and then see how I do. So let's look at this first problem here. It says, without using a calculator, match the expression to the correct point. So it says S, and it says negative 2 pi. So we know that if basically and let me actually change the, let me go ahead and, there we go. So, so let me go ahead and put, I mean, I'm not going to copy down the problem, but I will be going back and forth between the problem and OneNote so that you guys can know what I'm doing. But okay, so it says point S. So basically, the way that I would do this is this first one is, so we know that if you remember from 8th grade or maybe 7th grade, 6th grade, that pi is approximately equal to 3.14 units, right? Now, negative 2 pi really is just really equal to negative 2 times 3.14. So really it's going to be, so if we do multiplication for that, we have, this is 4 times 2, which is 8, and then 1 times 2 is 2, 3 times 2 is 6, and then we do 2 decimal places, and then and then the answer would be negative 6.28, right? Or negative 6 and 28/100ths. So that means that if we look on here, which one is very close to that? Well, here is negative 6, and this must be negative 6.28, right? Let me see, give me 1 second, guys. I'm gonna try to change the, maybe I can change the mouse really quick so y'all can see what I'm pointing at a little better. I wanna see if I can change it so that way, you guys can see my mouse a little bit better when I'm pointing at something. Give me 1 second. So if I go to I'm trying to see exactly how to change the mouse, let me look it up really quick, guys. Give me 1 second. I'm sorry. I need to, because I really want to make sure that that you guys can see what I'm pointing at. Okay, I think it's on, maybe it's in Bluetooth. So let's see, hold on. Or no, devices. So here, and then mouse. I'm wondering if I can... Okay, maybe that'll work. I know there's people that have done like I'm trying to see how they did it, because I don't know. I've seen people do with the mouse, like they've done what is it called? They've done like to make their mouse look like, I don't know, how do I oops, it's not what I wanted to do. They've done like, I don't know what it's called, but they've done oh, and I'm not sure why it looks like that now. Hold on, guys. Hold on. I don't know why it looked like that. Oh, that's not. I was trying to see, well, anyways, I'm gonna just move on. I don't know. I've seen people do, like, where their mouse looks highlighted, or it looks like a circle, like a with a yellow circle. I don't know how to do that. Hold on. Give me a second, guys. I'm gonna just try to do this really quick. I'll be right back. I'm gonna try to do this really quickly. And maybe I can connect my my other mouse if I can, so I can use it. Okay, well, I don't know. Never mind. I'm just gonna, every time if I'm pointing at something, I'm gonna just use the, like this here. Anyways, let's just move on. So, okay, so -2 pi, that is -6.28, right? So that's what t is. T is -6.28. Now negative the square root of 25, that's really just -5, right? Because it's negative square root of 25, that's -5. And -5, that's going to be over here. And we said that t was -2 pi, so that means that s must be negative square root of 68. Okay. Okay, now looking at this one, and maybe I can do snip and sketch for this. And let me just make sure that my sound is working, because I really don't know if it is. Give me a second, guys. I'm gonna just look in my YouTube really quick to make sure that my sound is actually working. Okay, there we go. It is working. Okay. So, okay, so let's look at this problem. It says, what is the measure of angle x? Now we want to go ahead and find this angle here. We want to know what this is, right? And we know, so I believe that when we have let's see, hold on. When we have like, so if we have something like this, right? Let's say we have two lines, and this is the angle that we're looking for, angle X, right? And I hope y'all can see that. So right here, this part, so we know that this is angle X, right? And let's see, we also know, let's see, and so the thing is, and this is not drawn to scale, by the way, but so basically what I'm trying to say is that I believe it goes like this. So basically, if we have an angle that looks I think maybe it's like this. If it's over here, then that means that, and we name this angle Y, right? Then that means that angle Y is congruent to angle X, I think. I think that's how it goes. Now, looking at this problem, we have 109, and we know that the degrees of a triangle is 180, right? So 180 minus the quantity 109 plus 42, that's going to be 180 minus the quantity, and if I get my calculator here, 109 plus 42, that's 151. So if I do 180 minus 151, that'll be 29 degrees. So I think that this is 29 degrees, so that means that this should be 29 degrees, I think. I'm not 100% sure. I think that's how it is. Let me try it. Okay, yeah, you see, so yes, that's what it means. That's why, and I believe it's called alternate exterior angles, something like that. I don't know my theorems very well, just so you guys know. So this one says 5 times the quantity y plus 2 equals 4x minus 3. Now, for this one, we have to solve, so obviously, this is not in slope-intercept form. We have to solve for y to find the slope-intercept form of this equation. So we have 5 times y plus 2 equals 4 times the quantity x minus 3, right? So we have 5y plus 10 equals 4x minus 12. So then we have, or actually let's do minus 10 on both sides. 5y equals 4x minus 22. So if we divide both sides by 5, we get y equals 4/5 x minus 22 over 5. So basically, the slope of the line is whatever's in front of your x value, or whatever's in front of your x variable. So it's going to be 4/5. This is 4/5. Okay. Okay, so this is, what is the volume of the cylinder? The volume of a cylinder is the following. So if we have a cylinder, right? The volume is pi r squared h, always. Now, the cylinder, and this is not drawn to scale, obviously, the cylinder has a radius of 4, and it has a height of 3. So that means that we're going to have, that the volume is going to be pi times 4 squared times 3. So it's going to be volume equals 16 pi times 3, which is really 48 pi. Now how much is 48 pi? Well, if we do 3.14 times 48, like this, we multiply it out, and that's 16, 1 over here, 4, 5, and then 3 times 4, that's just going to be 12, right? So, basically we're going to have 2, so it's going to be 1, 2, so it's going to be about 150.72. I think. Yes. Okay, so it says, click on the graph below to create a pentagon with the vertices at the following points. We have negative 8, 9. So to plot this, you're going to go on the x-axis, you're going to go 8 units left, right here, and then 9 units up, right here. That's negative 8, 9. This one. This one's negative 8, 9. Okay. Now it says negative 9, 7, so you're going to go left, negative 9, and then up 7. So it's going to be like right here. You see? That's negative 9, 7. Negative 9, 4, you're going to go again, left, negative 9 units left, or 9 units left, and then 7 units up, or I'm sorry, 4 units up. So right here. So that's negative 9, 4. And then negative 3, 5, you're going to go 3 units left and 5 units up. So right here. Okay. And then negative 4, 9, you're going to go 4 units left and 9 units up. Like that. And I believe, yes, I believe it's like this. You just go back. Once you plot the last point, you just go back to whatever point you started with. So negative 8, 9 would be the one that you would go back to, right? Okay, so it says factor is a product of 2 binomials. This is really just algebra. So if you don't know how to do this, basically, so we have 81 plus 18x plus x squared. We can rewrite that as x squared plus 18x plus 81. And if you do x box, so you have a times c, that's 81, and then on the bottom you're going to have 18. So it says 2 numbers that multiply to get 81 and add to get 18. If you think about it, it's 9 and 9, because 9 times 9 equals 81, and 9 plus 9 equals 18, right? Like, if you look at your, if you do a t-chart for your 81, like if you do like this, you do 1, 81, and then you do like, I think it's, I'm trying to think, it's 3, I think it's 3 and 27, and then it's 9 and 9, I believe. So looking at these two, you say, okay, 9 times 9, and then also what is 9 plus 9? 9 plus 9 is 18. 9 times 9 is 81. So these are your two values. So then you draw your box, and you always put your leading term here. Your leading term is x squared. On this part, you're going to put whatever's on your left side, so 9x, right? On your right side, you put 9x. Sometimes you would have to change the order of these two to know how to manipulate it so that you can kind of get the factors right. But in this case, since they're both the same, so basically this one and this one, sometimes if they're different, you're going to have to kind of change the order of it. But since they're both the same, you don't have to do that here. So, and then the last box would just be your constant term, which is 81. So here we're going to have x, and then this is kind of a times symbol here. X times x is x squared, x times 9 is 9x, and then 9 times x is 9x, and 9 times 9 is 81. So as a binomial squared, we're going to have x plus 9 quantity squared as our answer. Okay. So the way that you would write it is like this. Okay. Okay. Oh my, I literally forgot how to do this. Arc length. S equals arc theta. This one's interesting. Well, we know, so if I just look at this with snip and sketch, let me just kind of do this really quick. So let me get this out. So this one, we know that the central angle of this, because we know that a circle is 360 degrees, right? So what about a half a circle? Half a circle is just going to be 180 degrees. So we know that the central angle is 180 degrees. Now we know the formula for arc length, and I believe it's like this. S equals arc theta. Now, I believe theta has to be in radians. So 180, if you convert 180 to radians, you have 180 times pi over 180. So that's just going to be like this. It's going to be pi. So that would be, this is really just pi radians, right? Now, we know theta is going to be pi, and we know that the radius r is 5. So that means that S will be 5 pi, and they said they want us to use it, or actually, well, it says you can turn it, you can put it in terms of pi. So I believe it's going to be 5 pi. Hopefully it's right. Yes. Oh my goodness. Sometimes with these I feel like okay, so which slider creates skill copies of the shape? Now, okay, I'm going to try to define this very quickly. When they talk about scale copies, so for example, This is like the idea of similar triangles, right? If I have, for example, a triangle that looks like this, so let's say, I'm going to actually try to do it this way, so you guys can understand what I'm talking about. So like, if I have a triangle that looks like this, right? And then, or let me actually make it bigger. Like that. And let's say I go ahead and create a scale copy of this triangle, but I make it so that this triangle looks kind of a little more in the back. Think about it like it being behind the other triangle in a way. I don't know if that makes any sense to you guys, but or like kind of like a little smaller, but a little bit more further away, right? Because if we kind of get closer and closer and closer, eventually it'll look like this, right? But it's a little further away, so that's why it looks like this. That's what we call a scale copy. Now, this, if you think about it, because our original shape is a rectangle. If you look at it, it's a rectangle, and it's like this, right? I'm gonna just put it like that. The thing is, in order for the rectangle, so like, in order for this to be a scale copy, it has to be going like this. Like that, like this, or like this. Like either it has to be really a lot bigger than the other one, or it has to be a lot smaller. This, when it goes like this is not a scale copy. Okay, when it like rotate, when it translates up and down like this, then that makes this, the rectangle not be a scale copy. However, when it goes like this, then yes, it can still be a scale copy, because the more you zoom in, you can eventually, like let's say for example, it's like that, and then let's make this one, I don't know, let's make this one like this. So I mean, eventually, if you think about it, this one looks like this, right? Like if I make the view, so kind of, if I make the view like this, right? This is how it looks. Now if I zoom in a little more on this one, I can kind of see that it looks kind of similar to this one. But that would only be if I get really, really, really close to it. Like really, really, really close, which there's only a certain amount of closeness that I can get on this OneNote. But that's the point of this exercise, is that it's saying, so it's saying that no matter if you drag so basically the only way that a scale copy can be generated from this shape of a rectangle is if you drag the edge. Only if you drag the edge of it will it be a scale copy. This cannot be a scale copy, because that means it's going to get skinnier and skinnier, or wider and wider, so it's not really a scale copy. So I think it's going to be A. Okay. Okay, so graph the equation. Okay, this is algebra, and honestly, it's pretty funny because, I mean, it says get ready for geometry, so I'm assuming some of them are just going to be algebra. I'm guessing they just want to make sure you know your algebra pretty well. So let's do this one. We know that from this equation, the vertex is hk. This is written of the form a times, so let me write this down really quick. Or no, not whiteboard, no. Snip and sketch. Or full screen snip. I might just try to like look at this one a little separately. There we go. So this one is written of the form a times the quantity x minus h squared plus k, right? And we know that because, yeah. Now this, so basically we have a is equal to 5, we know that. And I'm not sure why it looks blurry, I'm really not sure, guys. I don't know what I can do about that. But a is equal to 5, right? And here, if we just look at this one, because this is really h. H is going to be equal to 1, and k is going to be equal to -5, because it's plus -5. If y'all hear a dog barking, I do apologize. I don't know why. She literally barks like all the time. Okay, so, let's see here. The vertex, so the vertex is going to be 1, -5, right? We know that. The vertex is going to be 1, -5. That's the middle of the parabola. 1, -5. Now, here's the thing. That's not the only thing that you are doing. If this were to be like, so you have to make sure that you plot another point in the graph, basically. I'm sorry, guys. Give me 1 second. I'll be right back. I need to... Give me 1 second, everybody. Okay, sorry about that, guys. Oh my goodness. Okay, so you have to plot another point. So here, you have to plot another point that's in the parabola. Now, you can, as long as it is not x equals 1, because that's literally going to give you this point here, because we already know what y equals when x equals 1. You can do x equals 2. So like, if you do x equals 2 for this, so for example, if I do, so y equals 5 times x minus 1 squared minus 5, right? And if I do for x equals 2, it's going to be y equals 5 times the quantity 2 minus 1 quantity squared minus 5, right? So it's going to be 5 times 1 squared minus 5. It's going to be 5. times 1 minus 5, which is 5 minus 5, which is 0. So when x equals 2, y equals 0. So it can look like this, I think. And then, I'm trying to think, x squared minus 2x plus 1. Yeah. Okay, so it says find the value of x in the triangle shown below. This is Pythagorean theorem. So Pythagorean theorem says, okay, so okay. Let's see here. Let me just draw it this way. Oh, I really wish this OneNote had screen to or ink to shape, but it doesn't. And then okay. So the side lengths, so we have this part is 6, this part is 10, and this part is x, and we have to find x. So Pythagorean theorem, anytime you have a right triangle, this is A, this is B, and this is C. So that's a squared plus b squared equals c squared. So that means that this is really just 6 squared plus x squared equals 10 squared. So 36 plus x squared equals 100. So then we solve for x by subtracting 36 on both sides. And then it's 64 equals x squared. Now you're going to take the positive square root, not the negative. So the positive square root would be x equals 8. And that's how you would do this one. Okay. So it says does coordinate P or coordinate Q represent a greater number? So which one represents a greater number? So to solve for P, Q, we know just from looking at the picture, it's very obvious that these two have the same slope. Okay? They have the same slope. So I'm trying to think about how to do this one. Okay. So, oh my, how do I do this one? I mean, I know how to do it, it's just, let's see. So we know that these two have the same distance, okay? We know that these two have the same distance. Just from looking at this picture, it's really, really, really obvious that these two have the same distance. That means that this line segment here, so if if you look at this line segment here, this entire part that I'm pointing with my mouth cursor at, it has the same length as this line segment here. So, to do this one, in reality, what you have to do, and I think I know, the reason why I don't do it like this is because I'm not 100% sure if this is the same as this one. I think it is, but I kind of don't want to risk it that way. But looking at these two line segments, we can find P comma Q. Now, we know that from 6 to 9, it adds 3. So that means that from P to 9, so if I kind of just draw a rough sketch of this, and I'm not sure exactly, the reason why I'm not doing this on a graph is because I'm not sure exactly where, like, so this is not going to be drawn to scale. I'm just going to, like, that. And I'm just going to go ahead and do this. Grab this and then move it. I'm going to just do it like this, okay? And then put this, put it right over here. Okay. This isn't drawn to scale, okay, guys? I'm not, yeah, obviously I cannot draw this perfectly, but let's just pretend that these two have the same length. So this line segment is congruent to this line segment. That's what congruent means. This is congruent. Let's name this, so let's name this A, B, and let's name this C, D, okay? And like I said, they are not, like, what I'm trying to say is that they're kind of, it's kind of at an angle, okay? So that means that this line here is not in the exact same place as it is on this line. So don't get that confused. That doesn't matter. This line doesn't matter. This line is just saying that they both have the same length. So AB, or let me just do it this way. AB is congruent to CD, okay? Now, okay, so point A is 6,5, right? We know point A is 6,5. Point B is 9,2. And then point C is PQ, right? And point D is 9,0. Now, obviously, like I said, this is not drawn to scale. So, basically, to know exactly, so basically the distance, we know that because AB, because AB, line segment AB is congruent to line segment CD, they have the same length, which means they have the same distance. So using the distance formula, we can find what P and Q are. So basically, we have 6, 5, and 9, 2. So we can find the distance between those two numbers. The distance, so basically 6, 5 we can name as x1, y1. 9, 2 we can name as x2, y2. And the distance formula says that the distance between any 2 points is the following: x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You can also write it like this. Like that. It doesn't matter. These two are the same thing. So if we do, so let's just name what x1 is. So x1 is 6, y1 is 5, x2 is 9, y2 is 2, right? So if we put it in the distance formula, we have 9 minus 6 squared plus 2 minus 5 squared. Yeah. And then that's going to be 3 squared plus negative 3 squared. That's going to be 9 plus, and then negative 3 quantity squared is just 9. And the square root. So it's going to be the square root of 18. So this, if you simplify the square root of 18, square root of 18 is really just square root of 9 times 2. This is the square root of 9 times the square root of 2, which is going to be 3 square root 2. So the distance between AB, so the length, let me just do this. So this whole length is going to be three square root 2, right? So now now we know that these two have the same length, right? Because it looks really, really obvious. It looks really obvious that these two have the same length, because look at this. It literally looks the exact same, unless this literally was kind of further away from the other one. But they're literally right next to each other. They are parallel. They're parallel lines. If you take, so for example, let me just kind of show you guys what I'm talking about. The reason why I say they're parallel is because if you take, so let's pretend that these are not there. And of course it's not, like I said, it is not perfect, but you can really tell that these two lines are parallel because they literally look like they have the same distance. I mean, there's no other way for me to explain that. At least I don't think. Let me try to do it this way. Hold on. So let's just kind of like do this here. I'm trying not to outline too much out, or not to take too much out, because I don't want to make it look crooked. But it is really clear that when you take those two lines out, it is very clear that these two lines are parallel. And there's a big reason for that. They both meet at a certain point. And this line, I wish I could really show with a visual representation, but this line, if I move it over here, it'll become this line here. This whole line here, so this line right here, this line right here, if I move it over here, it'll become this line. I really wish I could show you guys exactly what I'm talking about. Maybe on a graph I can show you what I'm talking about, but that's how we know they're parallel. You have to really look at it. You have to really look at it to understand it. That's why I say this class is very visual. Sometimes we have to see the patterns and the relationships of whatever shape they're giving us to see, okay, what relationships can we make out of this, and how can this help us answer the question? So, to answer this question, we use the distance formula, right? And we know that both of these have a distance of 3 square root 2. Now, this has a distance of 2 because in reality, if you look on the coordinate plane, let's just draw this out, and I'm going to draw this out after I finish this problem so that you guys can understand exactly what I'm talking about, because I really don't, I feel like me just explaining it this way is not enough. Let's see, hold on. And I know that some of us need a little bit more of a better explanation, or a more visual explanation, which, of course, I mean, when it comes to geometry, sometimes I also need a visual explanation of what they're talking about. So, okay. Give me 1 second, guys. I'm gonna try to graph this very quickly. So, let's see. Hold on. Let me just do like anywhere on this graph. I'm just gonna start a freaking... No, I'm gonna start a graph. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 2, 3, 4, 5, 6, 7. Okay, so this is going to be 0. -1, -2, -3, -4, -5, -6, -7, -8, -9. And then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, -2, -3, -4, -5, -6, -7, -8, -9. I'm going to go up to -11. So this is 1, 2, 3, 4, 5, 5, 6, 7, 8, 10, 11. -1, -2, -3, -4, -5, 6, -7, -8, -9, -10, -11. And let me do it up here too. So 1, 2, 3, 4, 5. And sorry if this is taking a second, guys. I'm just kind of trying to show you guys what I'm talking about. Let me make this up to 11. Sorry about that, guys. I don't know who's... Okay, so... I'm just gonna do it like this. And let me draw the graph really quick so that... Oh gosh, I really hope I draw this right. I know, guys, I'm a perfectionist. I really hate when I can't draw the graph correctly. Okay, so let's look at the problem. Okay, so it says we have 6, 5, right? 6, 5. So we're gonna go 6 units right, 5 units up. So here, 6, 5. Then it says we have 9, 2, which is right here. And then we have 9, 0, so this is 9, 2. And it says we have 9, 0. And I'm going to show you guys that that this in reality this has the same distance. Now let's see, hold on. If I do so here it went from 9, 2 to 9, 0. So that means that here it has to go from 6, 5 and has to go down 2 units on the y-axis. So it's going to be the same x-axis, so it's going to be 6, 3, I believe. So 4, 3 right here. And I'm going to see if, I'm pretty sure that they both literally have the same distance. So we said that the distance between so with the distance formula, we had said that the distance between those two was 3 square root 2, between 6, 5, and 9, 2, I believe. Was it 6, 5, and 9, 2? Yeah, 6, 5, and 9, 2. It was 3 square root 2. So basically, this distance right here between these two was, let me actually do it. Hold on. Yeah. It was 3 square root 2 units long. Now, if I say that this is in 6-3, I'm gonna prove to you guys that, so if I say A, B, and let me name this C, D, so this is 9, 0, just let me do it this way. And again, I'm only doing this because for those of you that really do not understand what I'm saying, when I had said about this problem that they literally, just from looking at it, they have the same distance. That's why I'm doing this graph. So if I do apologize if anybody's wanting me to speed this up. So looking at this, this is point D, and this is also 9, 0. Now, BD, if you kind of, so let me see, hold on. So basically AC right here, if you look at both of them, they're both congruent. It's really obvious because they have a distance of 2 units. 1, 2. This is 1, 2. So they both have a distance of 2 units. Now, we said the distance between this and this was 3 square root 2. So let's go ahead and prove that the distance, let's mathematically prove, or, you know, algebraically prove that the distance between CD is equal to the distance between the distance of AB, or the length of AB. So let's prove that. Obviously, point C is going to be 6, 3, so 6, 3 is here. So let's find the distance between 6, 3 and 9, 0. Okay, so this is x1, y1, this is x2, y2. So the distance between those 2 points is going to be 9 minus 6 squared plus 0 minus 3 squared. So it's going to be 3 squared plus negative 3 squared, which is 9 plus 9, which is 18. And then the square root of 18 is the square root of 9 times 2, which is really just the square root of 9 times the square root of 2, which is really just 3 square root 2. So that's how we know, and look at this. We had said that the distance of AD was, or not AD, AB was 3 square root 2. And the distance, so now the distance of CD is also 3 square root 2. So what does that tell us? That tells us that point C, which is the point that we were looking for in this part here, is going to be 6, 3. Now it's saying, and if we read the whole problem, it's saying, does coordinate P or coordinate Q represent a greater number? Now if we write this in terms of P, Q, so 6, 3 in terms of P comma Q, that means that P is going to equal 6 and Q is going to equal 3. So that means that P will be the greater number. Okay, so this is the answer. I know, guys, I took a really long time on that one, and that was because I really wanted to show you guys that, yes, I wanted to show you that, yes, those two had the same distance. That's why. I would have just put that, you know, found the coordinates of PQ and then just, you know, done it like that. But I really wanted to explain extremely well how those two had the same distance. Otherwise, it wouldn't have been well explained. So compare, and it says the square root of 0.88, and we want to know if those, so we want to know if those two are equal or if those two are greater, or like which one is greater, which one is less, right? So if we use the calculator, I mean, I don't think it would really matter if we use radians or degrees, because this is not trigonometry, so we're not using like tan or anything like that, or any of the trig values, so it doesn't really matter. So if we do square root of 0.88, that's 0.938, so it's like 0.94. So obviously, if you compare those two numbers, so 0.938 and 0.92, you can put a 0 next to 0.92. So in reality, looking at both of those, it's really obvious that the square root of 0.88, which is 0.938, is greater. Okay. Is figure B a scale copy of figure A? Now, this is what I was talking about earlier when I was talking about scale factor or scale copies of when I did the rectangle one. Yes, they are, because you can drag the edge of this triangle. So this triangle here, you can drag this little edge to make it look like this triangle here. So yes. Okay, without using a calculator, order the following numbers from least to greatest. So the square root of 72. Well, if we simplify that, so without using a calculator, right? This, we can say that this is equal to the square root of 9 times the square root of 8. Or we can also say that this is equal to the square root of 9 times the square root of 4 times the square root of 2. You can also do a factor tree, so you can say that this is equal to 9 times 8, which is equal to 4 times 2, which is equal to, and this is equal to 3 times 3, and is equal to 2 times 2. So then you have, so remember that when you have two numbers multiplied with itself on inside a square root, this is really just going to be 2. So for example, we have the square root of 3 times 3 times 2 times 2 times 2. So it's going to be the square root of 3 times 3 times the square root of 2 times 2 times the square root of 2. So it's going to be 3 times 2 times the square root of 2. Anytime you have a number, n times n, this is really just going to be n. The square root of n squared is n. Or it can be absolute value, but it's positive. It just means it's positive. It's always going to be positive, right? This is 6 square root 2. So the square root of 72 is 6 square root 2. Always look at the number in front of the square root. So if you just look at that number, that'll tell you, okay, ordering from least to greatest, it's going to be 6 times a decimal, because square root of 2 is really just a decimal. But it's really it's a small decimal, so it's not really going to make much of a difference, right? And then you're going to have 8 and then 9. So I believe it's like this. Okay, never mind. Looks like I was wrong. From least to greatest. Nine times 4 times 2, which is 72. And then 9, and then 8. I'm really not sure how it's not. $36 times 2 is 72. From least to greatest. I don't understand how this one's not correct. What is the square root of 72? Hold on. Oh, I see. Interesting. Okay. That's interesting. Because I thought, hold on, give me 1 second, guys. Okay, interesting. So this one is interesting. Okay. And like I said, yes, I'm not going to get every problem right. It's inevitable. Sometimes we make mistakes. Even people who do math, they make mistakes. This one, okay. So the way that they did this one is what they did, they squared all of them, right? They squared all of them. They said this is squared, and this is squared. So then they said this is 72, this is 81, and this is 64. So from least to greatest, it's 64, 72, and 81. Now putting it back to the way it was 8, and then square root 72, and then 9. So it was 8. That's why it was like this. Okay. So that's an interesting one. That's a really interesting one. Oh boy. Which shape does the intersection of the horizontal plane with the prism look like? I think it's this one. Never mind, it was this one. Oh my goodness. It looks really similar though. That doesn't make sense. The horizontal plane. Oh, because it's a 2x2. Okay. I see. I don't know. Some of these are pretty weird. It's like I said, I'm not perfect. I'm bound to make mistakes. So this one is a little bit more tricky. Let's see. The reason why I chose this one though is because it really looks like a rectangle up here. But I don't know. It says, which shape does the intersection of the horizontal plane with the prism look like? But what part are they talking about with the horizontal plane? Are they talking about whatever shape is created on the inside of this prism? Or are they talking about this shape here? You know what I'm saying? Like, are they talking about this shape? Like, that's right here? Or are they talking about this shape that's up here? You know what I mean? That's why this is a little tricky. But I almost got it right. It was either this one or this one. Okay, so it says, what is the scale factor from figure A to figure B? Obviously, if you look from 10 to 40, to go from 10 to 40, you have to multiply by 4. Similarly, to go from 11 to 44. So if you look at this little triangle, these are similar triangles. And if you look at this little triangle, it's really a scale factor. Now, that means that to go from this triangle to this triangle, you'd have to turn it 4 times bigger. That's because to make this distance to this distance, or to make this length to this length, you have to multiply times 4. So you have to go 4 times. You have to dilate it up. Like, you have to dilate it 4 units, or 4 times, by a scale factor of 4. And 18 times 4 is also 72. So the scale factor of this one. Now, if it were the opposite, if it were from figure B to figure A, you would have to divide by 4, which would be times 1/4. But that's not what they're saying. They're saying from figure A to figure B, so it would be 4. Okay. What is the slope of the line? So, okay. If we look at 2 points that we definitely know the point of, so like, we can look at the points 0, -3. Let me change the color. Hold on. 0, -3. This is 0, -3. And this is 1, -1. Now find the slope between those 2 points. To find the slope, we know that x1, y1 is 0, -3. That's because x1 is the least, the lowest x value. x1 is always the lowest x value. That's how I do it. I know maybe some others have done it a little differently, but I always do it as, like, x1 is always the how do I say it? x1 is always the lowest x value. Now, x2, y2 is 1, -1. So that means that the slope m is going to be equal to y2 minus y1 over x2 minus x1. So it's going to be m is equal to -1 minus -3 over 1 minus 0. So it'll be -1 plus 3 over 1, which is 2 over 1, which is 2. So the slope of this line is 2. That's one way you could have done it. Another way you could have done it is you would have grabbed this point, like go here and then go 1, 2, and then to the right 1. So that's how you would say the slope is rise over run. So it's like 1, 2, and then 1. Let me just show it really quick, and you could have done it like this. 1, 2, 1. So it's 2 over 1, which is 2. Okay. Rise over run. Find the area of the semicircle. So this is a half circle. Okay, this is a half circle. So what you're gonna do is you're gonna take the area of the circle. So it's gonna be pi times 4 squared, because the area of a circle is pi r squared. But it's because it's a semicircle, because it's a half circle, you're gonna cut it by half. So you're gonna divide this by 2. So it's gonna be 16 pi over 2, which is 8 pi. Find the volume of the sphere. The volume of a sphere, I think, so it's going to be volume equals 4/3 pi r cubed. So then you're going to have the volume is going to be 4/3 pi times 3 cubed. Let's just kind of do this. So let's do this in a way that looks, it's going to be like volume is 4 times 3 cubed over 3 times pi. This is 4, and then if you use the laws of exponents here, it's going to be 4 times 3 to the 3 minus 1 power times pi, which is 4 times 3 squared times pi, which is really 4 times 9 times pi, which is 36 pi. So it's going to be 36 pi units cubed. And when you do the volume, it's always cubed, units cubed. Okay, so the volume of a cone. Oh, I think it is 1/3 area of the base times the height. So it's going to be 1/3. So let me just simplify it for a cone. If you have a cone, and let me just let me do this really quick. Hold on. I'll do it like that. And then I'm just gonna I'm gonna grab the eraser and I'm just gonna go ahead and take that part out, and I'm just gonna kind of it's a little bit difficult to draw a cone, I'm not gonna lie. Now, of course, you wouldn't have time to do this on the exam, like on an actual exam, because you kind of already have to know. I'm just doing this so you guys can understand like exactly what I'm talking about. Because I know sometimes me just explaining geometry, like I don't know, from people explaining geometry without doing pictures or anything like that, or doing a visual representation of what they're talking about, for me it's always been so difficult. So that's why I'm doing pictures, and that's why I'm taking longer on these problems. So whoever's watching, like, I really do apologize. I don't, it's just how it is for me. I'm just gonna go ahead and draw a rough sketch. Or you know what? I'm gonna do it like this. Hold on. It's not drawn to scale, but it's whatever. I mean, a cone is really hard to draw. I used to know how to draw better. Okay, I'm just gonna like that. I mean, that's a rough sketch. I can't draw it any better than that. But anyways, I wish there was ink to shape on here. I don't think there is. I really don't think there is. But anyways, this, so let me see, hold on. It says it has a height, so let me just make this the radius. And it says it has a height of 4, even though I know, guys, I know that on, let me just do it this way. I'm gonna just take the grid off. So it's saying that this height is 4, and then it's saying that this radius here, and maybe I can try to like do, oh my goodness, this is like really annoying. Ugh. So it's saying this height is 4, like this, and then just gonna make this part a different color. This radius is, how much was it? It was 3. And there's a right angle right here, but we don't have to worry about that. We really don't have to worry about that. I guess they just try to like, that's kind of a distractor in terms of the what is it called? In terms of the actual problem, that's a distractor. I don't know why they put, I'm guessing that's just to show you that it does form, those two segments do form a right angle, but in reality you don't have to focus on that. But the area of a cone, or the volume of a cone is 4/3 pi r cubed. So you're going to say that this is equal to 4/3 times pi times, and we know that the radius is 3 cubed, so it's going to be volume is 4/3 pi times 3 times 3 squared. These two 3's cancel out, so then we have volume is 4 pi times 9. So then volume is going to be 36 pi units cubed. Or was it centimeters cubed? Oh, it's units cubed. Okay, yeah. So it's 36 pi units cubed. .36 pi. Okay. Was it 4/3 or was it 1/3? Oh, it was 1/3. My bad. That's why I got it wrong. Oh, it's 1/3, not 4/3. 4/3 is sphere. 1/3 is 1/3 is the cone. It's 1/3. Oh my goodness. You see, you have to be very careful. The thing is, between those two things, the volume of a sphere, so I'm just going to go ahead and write this down. I already wrote what the volume of a sphere was, but I'm going to write it down again. The volume, and it's actually pi r squared, I think, right? The volume of a cone, let me just look it up really quick. It's 1/3 pi r squared. Yes. So please do not confuse yourself with both of these. These are different, okay? A sphere, we all know how a sphere looks. A sphere looks like this, and it's like there's like a little circle in the middle, and you're just kind of going like this. Or really it looks like this, but, I mean, it looks something like this, so let me just kind of draw it a little bit. A sphere looks like this, so basically you have it looks I mean, we all know how a sphere looks, but I really want to make sure we understand the visual representation of a sphere. This is the radius, and the cone looks like this, and this is the radius, and this is the height, and that's why between these two there's a right angle, but we don't have to worry about that unless they literally ask us for the slant height of the cone. If they asked us for this height, then it would be different. We would have to know, like, we would have to use Pythagorean theorem, or if they told us the angle of this little part here, then we would have to use trigonometry, but yeah, so it would be 1/3 pi times and then times the height times 4, which is 36 pi over 3, which is really just 12 pi. So that is 12 pi, so it's going to be 12 pi units cubed. x squared plus 3x minus 4, that's going to be, so doing x box, we have 1 times negative 4 is negative 4, we have a 3 on the bottom. So doing this gives us, so this is our leading coefficient, or leading term, x squared. And then two numbers that multiply to negative 4 and add to 3 are negative 1 and 4. So we have negative x and 4x. And then our c value, which is our last term, is just negative 4. So then we have x times x, and then it's 4 times x, and then it's x times negative 1 and x plus 4, or 4 and negative 1. So then this simplifies as x minus 1 times x plus 4. And you have to put it all in parentheses like this. Okay. Okay, so complete the missing value in the solution to the equation, 5x minus 2y equals 30. So that one's pretty easy. Let me just put the rule lines back. So 5x minus 2y equals 30, and we know that the point that they're giving us is 8 comma y. So you're just going to substitute you're going to substitute 8 in for x. So that means that x equals 8 and y is equal to something. So 5 times 8 minus 2y equals 30. So you have 40 minus 2y equals 30. Minus 40 on both sides, you get negative 10 is equal to negative 2y. So then it's going to be negative 2. Divide by negative 2 on both sides, you're going to get y equals 5. So the coordinate, the missing value would be 5. Okay, so this forms a right angle. So 53 plus x, and we know that a right angle is 90 degrees. So that means that 53 plus x has to equal 90. So we subtract 53 on both sides. And we get x is equal to 37 degrees. Okay, and then this one is just asking for the third angle in a triangle. Remember that a triangle, any triangle that has angles x, y, and z, that means that angle x plus angle y plus angle z equals 180. Or similarly, if you had a triangle and it was angle A, angle B, angle C, that means that angle A plus angle B plus angle C equals 180. Now, there's something that I did want to explain really quick. When they give you a triangle, okay, let's just kind of say they give you a triangle. Or let me just do this with a, it's not going to be drawn to scale. I'm going to say that right now. It's not going to be drawn to scale, but I'll try my best. Let this be a different color. And then let this be a different color. And then let's see, hold on guys. And then let this hold on. 1 second, 1 second. Let this be a different color. So, how can I explain this? Whenever they say, so, actually, I'm just gonna do it like this. And let me just do it like this. Hold on. So, like that. Copy, paste, like this. I'm just trying to explain, like, in terminology. So, when they talk about, let's say they talk about, let's say this is ABC, right? ABC. So what I'm trying to say is that, for example, let's say they're talking about this part of the triangle, so this part. This is angle ABC. This angle here is angle ABC. Now let's say that hold on. Let's say this time they're talking about, so that's what this angle is. Let's say they're talking about, oh gosh. Let's say they're talking about, this angle here. What is that angle? That angle is going to be, so this angle here. That angle is going to be angle BAC. So that's what that is. Now let's say that they're talking about, and let me just do it one more time. And this is just really quickly so that you guys can understand the difference between all those three things. Let's say they're talking about, let's say they're talking about, hold on, guys, hold on. Let's say they're talking about this angle here. That angle is going to be angle BCA. Also, this can be renamed as angle CBA. As long as B is in the middle, as long as the angle that it's talking about, the real angle is in the middle, I can go C, so CBA, this angle here, right? Let's say that, so like, if I talk about BAC, angle BAC, I'm going to go BA Oh, actually, hold on. It's going to be B, A, B, A, C, like this. You start at B, you go to A, and then you go to C. Now, if I talk about CAB, it's going to be like this. C, CAB. Let me do that again. If I do that, if I talk about angle CAB, it's going to be CAB, like that. So this can also be defined as angle CAB. As long as, like I said, as long as A is in the middle, because that is your angle. A is your angle. A is the angle that is formed between those two line segments, between CA and BA. Now, or CA and AB. Now, this angle can be renamed as angle ACB. Okay, that's what I want to make very, very, very clear. Any angle, any triangle you have, you can rename it. Now, as far as this one goes, the angles in a triangle are always 180. So, if we have, let's just say we have a really random, I don't know, and I really wish that this had inked shape. It does not. It really does not. I don't know why. Maybe if I use this one note really quick. I don't know, maybe it might crash. I really don't know, but I'm gonna give it a shot. Give me a second, guys. Okay, well, never mind. So, I'm just gonna do it like this. Like that, okay? And it's saying that, two of the angles are 37 and 56, and like I said, they're not drawn to scale. And this is angle X, and we want to know what this angle is. So remember that the angles in any angles in any triangle add up to 180 degrees. So that means we're going to have 37 plus 56 plus X equals 180. So we're going to have, so this is really just 13, so it's 93 plus X equals 180. So then we're going to subtract 93 on both sides. We get 87 degrees. So this is 87 degrees. Okay. And then, okay, oh gosh. You've fallen into my trap, just in shouts laughing like the madman he is. The mouse he captured stares back at him indirectly as he munches on a piece of cheese at the bottom of a box whose base measures 12 by 12 centimeters. Okay, and it's saying that this is equal to 2 centimeters. So that means that if 3 squares are equal to 2 centimeters, that means that to get to 12, you have to multiply times 6. So that means that 3 squares times 6 will be 12 centimeters. So how many squares is that? That's going to be 18 centimeters, or 18 squares, excuse me. So really each of these line segments is going to have a total of 18 squares. So this is going to be 1, 2, 3, 4, 5, 6, and it's going to go all the way to 18. (12 by 12 centimeters). I really hope I'm doing this right. I don't know for sure. Okay, yes, like this. This is how you're going to do it. That's because, like I said, 2 centimeters is 3 squares, right? So, to know the number of squares, you have to do it. So really, it's 2 centimeters out of 12 centimeters equals 3 squares over x squares. So really, you kind of have to do some algebra with that. The way I did it was like this. 2 centimeters out of 12 centimeters is equal to 3 squares out of however many x squares is equal to 12 centimeters. Because it's saying it was 12 by 12 centimeters, right? So the way I did it was I did cross multiplication. So 2x equals 36. So divide by 2 on both sides. So that means that the number of squares to equal 12 centimeters is 18. So that's why I did all the way up to 18. And this is how many squares it is, right? So that's how I did that one. Okay, rewrite the equation by completing a square. So if you actually factor this, so x squared plus 14x plus 49, you're going to do a times c, so that's 49, right? 1 times 49 is 49. The bottom is going to be your middle value, so 14. And two numbers that multiply to 49, so if you do 7 times 7, that's 49. And then 7 plus 7 is 14. So it's going to be 7 and 7. Now you can, since they're the exact same thing, you can write this as x plus 7 quantity squared. And that is why this is equal to, that's why how you can rewrite this by completing the square. This is equal to 0. Okay, so we've done this before. What is the relationship between angle A and angle B? This one is, so anytime you have an angle like this, where it forms an X, kind of like a very narrow X, the angles in those two X's, like the little peak points, or the little peak, like these two angles here, these two lines, form an angle. Like this is A and then this is B. So if you really look at it, they're the exact same thing. And this is what we call vertical angles. Anytime you have So basically, vertical angles are like this. Where angle 1 is congruent to angle 2. This is what vertical angles are. Similarly, it looks like this. Hold on. Like this. Or you can also do, or like this. Right? Oh gosh. Okay. So this problem is talking about a beach ball, right? It's saying Ariel is filling a giant beach ball with air. The radius of the beach ball is 30 centimeters. What is the volume of air that the beach ball will hold? This is going to be, so, okay. It's saying that the beach ball is, so it has a radius, and I'm going to just draw it like this. It has a radius of 30 centimeters, right? But it's saying what is the volume? The volume of a sphere, like we said, I believe, and I think I said 4/3 pi r cubed. Yes. So that means that the volume is going to be 4/3 pi, and we know that the radius is 30 cubed. So if we do 30 cubed times 4/3, that's 36,000 pi. I think. Yes. Okay, so it says, identify the point in figure 2 that corresponds to point K in figure 1. So this is pretty easy. This one, you have to look at the points, right? Right here, if you look at it very closely, this point looks the same as this point. So that means that point K will correspond to point C. Okay, it says graph y equals -6. So anytime you have I think I went over this in my algebra review, or like my pre-calculus review or something like that. But anytime you have a constant C, it'll just look like this. Y equals a constant C where C is any real number. So it's going to be y equals -6, so we're just going to move this down to -6. And it does not matter how, like the distance, it doesn't matter the distance between these 2 points because it's always going to be equal to -6. Alright, and that concludes this, portion. So now we're going to do the actual geometry. What is it called? We're going to do the actual geometry challenge, and it's 30 questions. I think it's less than this one, but I don't know. I didn't see how many questions the other one was. Or I might have forgotten. I think I forgot. But anyways, it says which triangles are similar to triangle ABC. Okay. So, okay. Let me explain this. When a triangle is similar to another triangle, that means that it has the same scale factor. For example, I can say, let's say this triangle has a side length of 6, 5, and 4. And let's say I multiply those numbers by 4, right? That means that A, B, C, and then D, E, F. So if I multiply this by 4, I'm going to have right here 24, and then I'm going to have 16, and then I'm going to have 20. Because this is times 4, and then this one is times 4, and then this one up here is times 4. Now that means that AB is similar, not congruent. It is similar. This is the I think that's the symbol we use for similar. Oh, I don't know if it's 2 squiggly lines or 1. Oh, it's just 1. So the line segment AB is similar to line segment DE. That's how we know they're similar. Now, it is saying which triangles are similar to triangle ABC. So we're gonna try to do something, and we're gonna go ahead and just look at each of these triangles here. So the first one, to go from 0.9 to 4.5, if we use our calculator, we can do 4.5 divided by 0.9 to see how much that is. That's 5, right? So if we draw this separately, hold on, if we actually draw this separately, I'm gonna just do like a really rough sketch. A, B, C. 0.9, and then this one is 1, and this one's 1.5. And, so this one is kind of rotated. And these can get pretty tricky. And trust me, they can get pretty tricky because sometimes they look really similar, but they're not. Maybe if I do a snip and sketch of this, or a full screen snip. So this one, oh my. So, okay. If you you can visualize it by maybe turning your paper over, or whatever, your screen over, to see exactly what line segment corresponds to which one. So to me, it looks like, let's see, hold on. And these are very, very, very tricky. They're very tricky. If they're saying that ABC, if triangle ABC, so basically, let me just draw the other one really quick. I think it was like something like that. even though it doesn't look perfect. So this is DEF, right? DEF. This is DEF. If they're saying that triangle ABC, hold on, triangle. Okay, hold on, guys. I don't know what happened. That means, okay, so if triangle ABC is congruent to triangle DEF, that means that line segment AB must be similar, or sorry, not congruent, similar. If triangle ABC is similar to triangle DEF, that means that line segment AB must be similar to line segment DE. What do I mean by that? So this is 4.5, this is 5, and then this is 7.5. That means if I say that line segment AB is similar to line segment DE, this line segment, if I say that is similar to this line segment, then that means that the scale factor, that means that that means, for example, I believe, and this is where it gets very tricky. I believe it goes like this. Let me look it up really quick. I do not remember this stuff. This is one thing in geometry that I always forget. Oh my goodness. This is one thing that I always forget. Always. It's very, very tricky. Because I don't remember if it goes AB over DE is equal to BC over what would it be? Or actually, hold on. I think this is so tricky. Oh my goodness. I think it's the other way around. Never mind. It is the other way around. 1.5 times 5. Actually, no, I'm right. This would be multiplied times 5, and then this, or actually no, this one would be multiplied times 5, and then this one would be multiplied times 5. I think that's how it works. It's been a long time. It's been a long time since I've done these. DEF, and then, oh, yeah, it's that one. Oh my goodness, that one's very tricky. I don't think it's this one, because this one, I mean, it does not look dilated. This one looks like the, because remember, similar triangles, for the triangles to be similar, you have to have one that looks like this, and it has to be dilated. So it has to look like either like this or like this. If it's, for example, if I have a triangle that looks like this, and let's say that I change, I don't know, like, let's say that I make it like either narrow or higher, then these two are not similar because I changed the width of it. I did not change the I did not change how like, basically I did not grab the edge and change from the edge and change how it looked. It has to be from an edge. It cannot be from the side or from the actual height. It has to be so basically it has to be either magnified up like this or put far away like this. It cannot be like this or like this, because if you do that, then that's gonna make it not similar. I don't know how else to explain that. That's really, really hard to explain. That's the best way I can explain it. Okay, this is something that I'm just like kind of not good at. It says ELM is rotated negative 90 degrees about the origin. So, there are rules to this, okay? If you rotate a triangle 90 degrees, so if it's negative 90 degrees, that means it's gonna go. So, the best way I can explain this, for example, let me go down. This, so, okay. This is 90 degrees. This is 180 degrees. So, like, let me just explain this. This is 90 degrees. And then if I go like this, that's 180 degrees. If I go like this, that is, like this, that is, 270 degrees. And then if I go like this, that is 360 degrees. Now, if I go the opposite direction, gosh. If I go the opposite direction, so this is 90 degrees. So if I go the opposite direction, I'm going to say that so this is always, so one of the things that you have to know is that this is always the initial position, and whatever you're rotating it by would be the whatever you're rotating it by would be the terminal position. So basically, like, you're always going to start at 0 degrees. This is 0 degrees. Don't worry about the initial position. Just worry about, like, this is 0 degrees. You're always going to start here at 0 degrees. This is 0 degrees. Now, if I go 90 or negative 90 degrees, I'm going to go this way. So it's going to look like this. If I go negative 180 degrees, so if I go like this, that's negative 180 degrees. And if I go, let me make it a little bigger. If I go negative 270 degrees, it's going to look like this. And if I go, or sorry, I keep forgetting, like this is negative 270 degrees, okay? Like this. And if I go negative 360 degrees, it's gonna look, let me make the line a little bit bigger. It's gonna go like this. So, negative 360 degrees is gonna go like this. Like this, with a little arrow going here. This is the arrow going like this, and then like that, and then like this, and then like this. So you see the difference? And let me do this for all of them. So it goes like this, so like that, and then it goes like this, and then it goes like that. Okay, that's what the difference is. That's the difference between these two things. When I say, so positive n degrees looks like this. And where this is your angle n, and negative n degrees would look it would look like this. Hold on. It would look like this. So right. Now it's saying 90 degrees about the origin, okay? Let's just kind of outline the triangle first, okay? We're gonna just outline it. If I go negative 90 degrees about the origin, that means that I'm gonna turn this, so I wish I had a way to do this. I wish I had a way to do this, like a proper way to do this, a proper way to show this, okay? You're gonna turn your paper, like if you have a paper, you're gonna turn it this way. So like, you're gonna rotate it horizontally. I don't know if they ever showed you. So for example, if they ever showed you something like this, where you have, because I'm sure my teacher taught me this in geometry, where you have something like this, right? You have like a Cartesian plane, and let's say this is, let me color code so that way you guys can know what I'm talking about. This is y, this is negative x, let this be negative y, or actually, I'm gonna do, let this be negative y, and then let this be x. If you rotate it 90 degrees clockwise, so it's gonna look or actually, hold on. Oh my god. I believe it'll look like this. Hold on. So it'll look like this. Or sorry, no, hold on. It's like this. X, and then Y, and then negative X, and then negative Y, like that. That is if it's 90 degrees clockwise. If it's 90 degrees counterclockwise, it's gonna look like this. Hold on. If it's the other way around, it's gonna look like this. Hold on. So this will move over here. So this will go over here. This will go over here. This will go over here. And this will go over here. That is if it's 90 degrees clockwise. If it's 90 degrees counterclockwise, this will move over here, this will move over here, this will move over here, and this one will move over here. This is 90 degrees counterclockwise. That's why I did it this way. When I put it to, or sorry, this is supposed to say counterclockwise. Oh my gosh. Counterclockwise. And this one, so that's how it would look counterclockwise. Clockwise would look like this. So if you do it clockwise, you're gonna move the Y. So basically the Y would be over here, and then the X would be right here, and then the negative Y would be over here, and then the positive, or the negative X would be right here. There is no other way I can explain it. They did a whole video based on like, and maybe I can do a short video about this on my YouTube or my shorts video, but and I will post the link in the description down below once I do once I do make it, because I haven't made one yet, but I will explain this once I do make it. Okay, so okay, so basically this is how it would look not counterclockwise, clockwise. This is clockwise. This one is clockwise. 90 degrees. Now, if you want to go 180 degrees clockwise, or actually, well, no, actually, negative 90 degrees. So it's going to be 90 degrees counterclockwise. So it's going to look like this. So basically, our triangle, let me just go ahead and plot this. Or let me look at this triangle. So basically, if I just kind of do a snip and sketch really quick of this triangle, or full screen snip. I keep saying snip and sketch because that's what this is called, snip and sketch. Right. So okay, I'm gonna try my best to like really explain this. if it's 90 degrees clockwise, that means that the graph will look like this. It's gonna go x, y, and then negative x, and negative y. That is if it's 90 degrees counterclockwise. So again, counterclockwise is negative degrees, or negative angle, right? Negative n angles, if that makes any sense, because it's however many angles it tells you to rotate by. So this is going to be, so really, if the point is at 6, 7, then that means that it's going to go, so we have y equals 7, so y is 7, and x is 6. It's like right here, right? But what is that in terms of real Cartesian plane, like the real coordinate plane? What is that in the real coordinate plane? Because we cannot have, this is not really y, and this is not really, like this is not really negative y, and this is not really y. It goes negative x, x, and y, negative y, like this, negative y, y. So basically, on this, if we just take this off after we're done doing the rotation, so basically, or actually, let's do all of them first. So 90 degrees about the origin, so we already rotated, so we went 6, 7 here, and we rotated 90 degrees, so it went like this. It went negative 7, or I mean, it went, yeah, it went negative 7, 6. So negative 7, 6, which is like right here. So that is really just 90 degrees. So that's angle, or that's m prime. We're going to say m prime right there. Now, this one, which is 3, 2, like this. 90 degrees about the origin. Again, if we were to look at this in terms of, it would be, if, again, this is how it would be in the negative 90 degree rotation. So then we would have, so we know that x equals 3 and y equals 2. So that means that we have to make it look like that on here. We have to make y equal 2, so 2 would be like right here, and then x equals 3 would be like right over here. So it would be right, kind of like right over here. But again, in the real coordinate plane, if we take off, if we just ignore the parts we made over here, if we ignore it, and if we say that this is really x, negative x, so it's really going to be negative 2, and it's going to be, how much was this? It was, so it was 3, 2, and then that means it's going to be, hold on, negative 2, this is 3. So this is going to be negative 2, 3, right? And then, so that means that negative 2, 3 is going to be like right here. So negative 2, 3 will be right here. This is going to be L prime. Now for E prime, we're going to do the exact same thing. You turn, so basically, so point E is at 7, negative 3, right? So we know that for point E, x equals 7, y equals negative 3, right? So then, if we do a 90-degree rotation, then that means that on here, it's going to be, so we know that x is 7, it's going to be right here, and y equals negative 3. It's going to be like right here. So it's going to be about over here. Now what is this? Or actually, hold on, not there, over here. This is going to be, and I forgot to write the coordinate points, but 7, 6. This is M prime. And then this is, hold on. This is L prime. And this is, E prime. So, in reality, for E, we know that x equals 7 and y equals negative 3. So, on the real coordinate plane, I believe it's going to still be over here. Oh, this is hard. This is confusing. Hold on, guys. Oh, boy. It's gonna be... These can get very confusing very quickly. I'm not even joking. So 3, 2, right? 3, 2 was like right here. Oh my goodness. Okay, oh my gosh, it's a little confusing. Give me 1 second. It's going to be clockwise. It's really going to be clockwise. It's not going to be counterclockwise, right? Okay, so let me try to explain this, okay? This one's really hard, okay? So I'm really trying to explain this in the way that we can do it without looking at a cheat sheet or something like that, because I really want to explain to you guys exactly why it is the way it is and why we work it out the way we work it out. So this is 7, -3, right? If you turn your paper, it's going to be this way, right? So it's going to be, so in reality, it's like I said over here, yes, we're going to have this, right? So that means that it's going to go, negative, or really it's going to be negative x, or it's going to be, so if we do this, so like if you turn this graph like this, so if you kind of rotate your head about 90 degrees like this, right? I really wish I had like a way to explain this better, but I don't. And that's why I'm probably gonna make a short about this on my YouTube channel. Because honestly, I don't know exactly how else to explain this. This is a little bit hard to explain. So, okay. So really, it's like I said, if we rotate, so I'm just gonna do it like this, hold on. If we have a coordinate, so that it's like I said over here, right? We go from x, so we go x, y, and then negative x, negative y. If it's counterclockwise, or what was it? So if it's negative degrees, that means it's going to be clockwise. So this is clockwise, right? And we know that for the 3 points, for example, that M, we know that M is 6, 7, right? That's point M. Point M is 6, 7. That is located like right over here. Now, if we rotate it clockwise, that means that right here, if y equals 7 and x equals 6, it's going to look like this. We have to follow the clockwise picture over here, this point. So it's going to look like this. It's going to be, this is going to be 7, and this, or actually, no, not that, hold on. Seven, and then it's going to be 7, and then you're going to do 6 right here. So it's going to be like right here. So that's going to be, this is, so basically if we write it in terms of like this, so basically if I go from, x, comma, y, if I do 90 degrees clockwise, CW for clockwise, that is going to be y, comma, But it's like I said, we cannot have y comma x, right? That's why when I looked at this at first, I was really confused. I was like, why would it be y comma x? Okay, the thing is, that's the reason why it's like that is because they make this picture, okay? But if in real, like I said, in real Cartesian plane, in the real coordinate plane, because we cannot have a plane that looks like this. We have to have it like this. So really, or I'm sorry, we have to have it like this. We have to have it looking like this, where this is x, this is y, this is negative x, and this is negative y. We always have to have it like that. So, in reality, you would say, so, for example, the 0.67, let's just say that we have the 0.67, comma, 7, okay? This would be 7, comma, 6. However, in x, y form, it would be, like in actual xy form, like literally, you would just say that this is x equals 7, y equals 6, because this is the new point that you have after you rotated by 90 degrees on the real coordinate plane. I really don't know how else to explain it. Like, you have to convert it back to the real coordinate plane. So in reality, the point would be, so if I have 6 comma 7, or actually, hold on. Actually, if it's clockwise, it's yx, but look at this, because this is located in quadrant 4. Quadrant 4 is x negative y, so it'd be 7 negative 6. So really, in reality, 90 degrees clockwise would be y comma negative x, like this. And then, so basically this would be, so if we have the point, if we have the point 7, 6, or I'm sorry, 6, 7, this would be 7, negative 6. And then you would say, in real coordinate plane, or in real Cartesian plane, it would be x equals 7, y equals negative 6. So really, this point, that is 90 degrees, would be, so let me see, hold on. This point would be, so point M would be 7, negative 6. Okay, that's what it would be. And then L would be like So it's x equals 3, y equals 2. So then it would be, again, y negative x. So x equals 3, y equals 2. So it'd be 2, negative 3. So then x equals, so then it would go after 90-degree rotation clockwise, it would be x equals 2, y equals negative 3. So you would just do 2, negative 3 for point, I think it was point L. And then point, oh gosh. Oh my goodness, this is so difficult. L prime. This is L prime, and then 7. Okay, so it's 7, negative 6. 6, 7 would be 7, negative 6. And then so that means that point M, or I'm sorry, point E prime would be so if we do E prime, so we have 7, negative 3. In 90-degree clockwise rotation, it would be 7, comma, negative of negative 3. Or I'm sorry, it'd be negative, I think it's negative 3, comma, negative 7. This is like really hard to explain, and it's really hard to do. Oh my gosh, and I didn't even get it right. This is really hard. It is one of those skills that I'm really not good at. Okay, so which triangles are similar to triangle ABC? Oh gosh. Okay. So I don't think it's either of them, because one of them would have to be one of these numbers, and they're not. Let me see. Yeah, exactly. So basically this one, if one of them was similar, they would have to have a similar number. Like, the only similar number they both have is 90, but that's because, I mean, like this one, it has 90, but it also has 52, but then, like, this one doesn't even have a 52, so it can't be this one. And then this one isn't even a right triangle. It's like, I mean, no, it doesn't even have 30 degrees either, or 53 degrees, so it can't be this one either. So it's neither of them. Okay, so I'm better at translations. I'm so sorry, guys. I don't know why that, like, took me so long to explain about the rotations. I was trying really hard. If I do, so let me just outline the quadrilateral here. Okay, so it says 1 unit to the right and 6 units up. So I'm going to do 1. At point C, I'm going to do 1, and then I'm going to do 1, 2, 3, 4, 5, 6. Point D, I'm going to do 1 unit to the right, so 1, and then I'm going to do 1, 2, 3, 4, 5, 6, right here. And then point B, I'm going to do, so again, it's going to be 1 unit to the right, so 1, and then it's going to go 1, 2, 3, 4, 5, 6, right there. And then point A, it's going to be 1 unit to the right, so 1, and it's going to go 1, 2, 3, 4, 5, 6. Oh gosh. I don't know this one. I don't know this one. I can't. I really don't know that one. That one's really hard. I don't know this one either. Okay, so a circle has a circumference of 10. It has an arc length of 2, or 9 over 2. What is the central angle of the arc in degrees? Okay, so I think it goes like this. Hold on. This is 9 over 2, and that's 10. And we want to know what the central angle is. So basically this. So like, they want to know what this is. So that means that S equals arc theta. It's saying that it has a circumference of 10. So that's the total circumference. Oh, and actually, so this part here, this one, is actually the arc length, because this is the arc. An arc is really part of a circle. This entire circle, it's saying that this entire circle has a circumference of 10. So that means that from here all the way, or really, I'm gonna just do it this way. From here all the way to here, like this, that is 10. That means that this whole part here, so basically, let me just do it this way. It's basically saying this entire part of the circle is 10. Now it's saying that only this part, it wants us to know what this is. What is this? Or, I'm sorry, no. What is this angle? So we know that S is equal to arc theta, but we don't know the radius, but we can find the radius. Circumference equals 2 pi r. And we know that the circumference is 10, so 10 equals 2 pi r. So then 10 over 2 pi is equal to r. So if we do 5 times 2 over 2 pi. That's going to be 5 over pi. So then in reality, the radius is going to be 5 over pi units. And then that means that the arc length is going to be 5 over pi times, and then theta it's just going to be like that. And we know that S, so the arc length is 9/2, so that means that 9/2 is going to be equal to 5 over pi times theta. So really it's going to be 5 theta over pi equals 9/2. So then that means that 10 theta equals 9 pi. So if we do pi, or like if we convert pi to rate or to degrees, that's really just 180 degrees. So that means that 10 theta is going to be 9 times 180, because pi is 180 degrees. So then we have, if we do 180 times 9, that's 1620, so 10 theta is 1620. So if we divide both sides by 10, we get that theta is 162 degrees. That's literally how I can do it. That's the only way I can do it. I mean, I don't know how else this would be done. What is the area of the sector? Oh gosh. The area of a sector, I literally forgot the area of a sector. Okay, wouldn't it be pi r squared theta? Or no, am I wrong? Am I wrong? Let me see, hold on. So it's going to be theta over 2 pi times pi r squared. So really, it's going to be, okay, hold on. So we know that theta for this one is pi over 6, right? And then we know that what else do we know? We know that r is equal to 12, right? So they say that the area of a sector over here is pi over 2, or I mean theta over 2 r squared times r squared. So basically it's going to be r squared theta over 2. Apparently. yes. Because really they're saying this is equal to, so area of a sector is really going to be theta over 2 pi times pi r squared. This gets canceled out, so then we're just left with theta r squared over 2. That's what area of a sector is. And yes, I had to look it up because I really don't remember. So we're told that theta is pi over 6 and r is 12, so then we have, so then if we color code here, this is theta, so it's right here, and then r is literally just this part. So then we can say that the area of this sector is going to be pi over 6 times 12 squared over 2, all over 2. So it's going to be 144 times pi over 6 over 2, which is really 144 pi over 6 times 1/2, which is really 144 pi over 12, which is really just 12. It's going to be 12 pi. Okay. Okay, so it says, which of the following reflective symmetries apply to a triangle? So, if you look at this very, very carefully, just looking at, like, literally looking at it very carefully, just looking at the line y equals 1/7 x, 1 over 7x plus 3, you can realize right away, or you can tell right away, that it is a reflection across that line, that the triangle is a reflection across that line. So it says, so it has a reflective symmetry across the line y equals 1/7 x plus 3. Now, it's also asking if it has a reflective symmetry across the line y equals 4. It doesn't, because if you look at it very closely, and let me show this very quickly. So if you look at it very closely, the oh gosh, this is not what I wanted to do. Hold on. So the reason why I say that this is not a reflection to this, so basically it's going to go 1, 2, 3, 4, but then it wouldn't make sense, because then you would say, okay, if you go 1, 2, 3, 4 units again, it would end up over here. I think I did that right. Hold on. 1, 2, 3, 4. Yes. 1, 2, 3, 4. Yes. So this would be if it were reflected across y equals 6. Or y equals 4, excuse me. So that can't be what the triangle is representing. That cannot be what the triangle is representing, because it's not on the actual triangle that it's reflecting over. So it has to be a reflective symmetry across the line 1/2, y equals 1/2 7th, or 1/7 x plus 3. Okay. Okay. This one is really, it's not really that hard. It's, so 5x minus 5 over 2x over x minus 2 equals 1/3. Oh my gosh. So you're going to do cross multiplication. You're going to go like this. So that means a over b equals c over d. If a over b equals c over d, then AD equals BC. So you would say x minus 2 equals 3 times 5x minus 5. So you would say x minus 2 equals 15x minus 15. So then you would subtract x on both sides. You would have negative 2 equals 14x minus 15. Add 15 to both sides. You would get 13 equals 14x. You would divide both sides by 14. You would get x equals 13 over 14. I think. Yes. .15 is the image of, so P prime, which is 1,5, is the image of P negative 3, 1 under a translation. So determine the translation. So if I go from, okay, they're saying that P is negative 3, 1, right? Negative 3, 1, that's P. P prime is 1,5. Now, how do I go from negative 3 to 1? If you draw a number line, I'm going to go 1, 2, 3, 4. I didn't do that correctly. Hold on. 1, 2, 3, 4. This is 1. So that's about 4 units. So to go from here to here, it's plus 4. Now to go from 1 to 5, obviously it's going to be plus 4 again. So, but at the same time, it's x and then it's y. So if I go up in the x direction, if I go from negative 3 to 4 to 1, it's going to be 4 units right. If I go from 1 to 4 in the, or 1 to 5 in the y direction, so negative 3, 1, and 1, 5. Or I'm sorry, negative, so if I go from 1 to 5 in the y direction, so right here, it's gonna be 4 units up. This is 4 units, and this is 4 units up, and then this is from here to here, and then from here to here, it's 4 units right. I really hope that makes sense. So 4 units to the right. And 4 units up. A circle is centered at negative 1, 3. The point G, negative 10, 1 is on the circle. Where does the point J, 3, 12 lie? Okay. So, we have to, okay, so it's telling us that a circle is centered at negative 1, 3. Okay. So, I'm just gonna grab Desmos here. So let me just go to Desmos. Because, like, there is no other way in which I can do this. Like, I feel like this one's a little bit tricky. So it's saying that the circle is at negative 1, 3. So, or there's a point on the circle, negative 1, 3, right? Where was I? Hold on. So it says it's centered at negative 1, 3. That's the center of the circle, right? So let me go to my thing here. Negative 1, and then it's 1, 2, 3 right here. This is the center of the circle. Okay, now it's saying that there is a point, and of course, you can draw a line segment from that point, right? So negative 10, 1 is on the circle. So negative 10, 1 is like right here. This is negative 10, 1. And so if this is the center, so let's just kind of draw, that means that if that's the center, then that means that the circle where negative 10, 1 is, that's going to be a line segment on the circle. Now, it is saying, so basically what is the, maybe I can do it like this. I don't know. I'm not 100% sure if this is how I can do it. Maybe. So if I go like this, now let's say you don't really know how to like draw a circle like that. It's fine. But you can find the radius. So basically you can do the distance formula. So you can say that x1, y1 is negative 10, 1, and x2, y2 is negative 1, 3. And I know that because, again, you're going from left to right on the x-axis, so whatever the smallest x is always your x1. And then y1 is whatever point that coordinate has, or whatever y value the coordinate has. And then x2, y2 is just the second part. So then you can use the distance formula. You can say that so basically you have x2 minus x1 squared plus y2 minus y1 squared. So then it's going to be the square root of negative 1 minus negative 10 quantity squared plus 3 minus 1 squared. This is equal to negative 1 plus 10 squared plus 2 squared, which is really 9 squared plus 2 squared, which is really 81. The square root of 81 plus 4, which is really the square root of 85. So this has a radius of square root 85, right? Now go ahead, and it's saying, let's just pretend we never drew that circle. It is saying, what is the distance, or what is, where does the point, what did it say? It said, where does the point negative 312 lie on? Where does point J lie on, right? So what you're going to do is you're going to plot negative 312 on the coordinate plane. So you're going to do this, basically. 1, 2, 3. And you're going to go all the way to 12. So I think it's like right here. This is negative 312. So that means that I mean, you can do this using Pythagorean theorem, where you say that this distance, this distance and this distance are both like basically, I'm not saying that they would be the same, but like, or maybe they would actually. So what I'm trying to say here is you can use the distance formula again for that part, or you can use Pythagorean theorem. I would use the distance formula again, just because with Pythagorean theorem it can be a little bit more trickier. That's just my opinion. If you know how to do it using Pythagorean theorem, you can do that. But if I want to find, this distance here, right? Then so basically from negative 312 to negative 1, 3, the distance, and this is x1, y1, this is x2, y2, it's going to be 3 minus 12 squared plus negative 1 minus negative 3 squared. So then I have square root of negative 9 squared plus negative 1 plus 3 squared. So then I have 81 plus 2 squared, which is 81 plus 4, and it's the square root of 85. So look at that. You see, this distance is also square root of 85. From negative 312 to negative 1, 3. It's also the same thing. So what does that tell me in reality? That means that it would be on the circle, right? Because if they're both equal, if the distances are both equal, so basically, if we have a circle, so let me just draw a circle very quickly. Any circle, and let's say that we have let's just say from the center, I'm just going to draw like a very rough sketch of this. If, so basically, if point R, so if point R is on this, if points R and Q are on the circle, then and let's name this E. Let's name this point E. Then that means then line segment ER is congruent to line segment EQ. Okay, I don't know why. Hold on. EQ, okay. That's how it would be if they're both on the circle. Okay, that's the rule. So that means they're going to be both on the circle. Pyramid A has a quadrilateral base, a height of 4 units, and a volume of 20 cubic units. Pyramid B has the same base area, but its height is 12 units. What is the volume of Pyramid B? So let me go ahead and look at this. Okay. Let me look up the area of a pyramid because like I said, I don't remember. It's been a while. Not surface area. Oh my gosh. Or volume. No, I mean volume. My bad. Not area. Volume. Volume of a pyramid. Okay. Okay. So, okay, this one's interesting. So, I believe that so the first one has a height of 4 units. The volume of the first one is 20 cubic units. And Pyramid B has the same base area. So this one has a so the area of the base, which is this part here. So it's this part here. That's oh my. That's tricky. Hold on. So they both have the same base area according to this. And the volume of this one is 20. So that means that the volume is 1/3 times A times 4. So really the volume is 4/3 A. And it's saying that this has a volume of 20, so really it's going to be 20 equals 4/3 A. So it's 20 equals 4A over 3. So 4A equals 60, so then divide both sides by 4, we get A equals 15. So this must be 15. Now, pyramid B has the same base area. So that means that B has to also have the base area of 15, but the height is 12 units. So that means that if we do 1/3 times 15 times 12, that's going to be 5 times 12, which is 60. There we go. Oh my goodness, that one was a little tricky. Okay, it says use one of the triangles to approximate the ratio WY over WX. Oh boy. When the angle is 70 degrees, so let me see, hold on. I need to look at this. Okay, that's very interesting. WY over WX. So that means, so if we were to like reflect this one to the other side, it would literally look like this. I'm talking about this one specifically, this triangle here. If we were to turn this over, then the hypotenuse would be 10 and the side length would be 9.4. So that means that this, so what I'm trying to say here, and I really wish I could zoom out a little bit more, I can't. Okay. Let me try to look at this one. So let's see, hold on. This is tricky. I'm trying to figure out how exactly they're doing this one. So, so this is really turned over. This one's a reflection. Okay. So really, we would have something like this, and then it's like 70 degrees, and then it goes 20 degrees. So then, let's see, hold on. This is 10, and this is 3.4, and then this is 9.4, right? Oh my goodness. So WY, so really, okay, so this is WY, and then this is WX, right? So that means it'll be 3.4 over 10. And that, if I do it on the calculator, 3.4 over 10, that's 0.34. So the answer to this one would be 0.34. It would be A. Okay, there we go. Oh my goodness, that's a little tricky. Interesting. Oh, this one's tricky. This one's tricky. I don't know this one. This one's tricky. Because I mean, I'm assuming it's let me see, hold on. So it goes 1, 2, 3, 4, 5, 6. And then it would go 1, 2, 1. It would go, so, okay, so let me do it this way, hold on. If they were to literally do this one, that's what I'm saying. I feel like I really have to think about these problems when I do them sometimes, because I feel like sometimes it can get a little tricky. You have to think about it for a second. So this one, it would be 1, 2, 3, like right here, and then it'll be 1, 2, 3. So then this one would be like 1, 2, and then it'll go 1, 2. So hold on. It would go 1, 2, and then it'll go again 1, 2, right? And then this one would be 1, 2, 3. So then it'll go 1, 2, 3. So really, this triangle here is kind of the middle of all the... It's like the middle triangle of the dilation. But I don't know, and I really don't know. I think it would be B. I think. Because honestly, oh, this one's tricky. I don't know this one. Interesting. Okay. So I think when it's talking about the center of dilation, that's just really strange, though. I don't understand how it's point C. Oh, I think I know what it's talking about. It's because these two triangles, if you kind of visualize this as a 3D figure, these two triangles are within this pyramid here, or this triangular prism. They're within, right? So that's why C is the center of dilation. So basically, that's how I see it. I feel like, I don't know if you guys know what I'm talking about, but basically like right here, this part here, it's kind of going inside the triangular figure here, the 3D figure. So that's how I see it. And this is where it starts. This is the starting point. So I think that's why it's point C. It's really weird. It's a really weird question. If the astronomer's telescope is currently pointed at star A, how many degrees must she rotate her telescope to see star B? Okay. I think we have to use laws of cosines for this one. So I'm just gonna do it like this. $4,001. Wait, hold on. Oh wait, no, 400. It's 400. So it goes 400, and then it goes 450, and then it goes 900 or 90. Yeah, 90. So let's name this A, B, C. So really, we have, this is going to be C, this is B, and this is A. So that means that C squared equals A squared plus B squared minus 2AB cosine of C. And I believe, I mean, I'm going to do it this way. Hold on. So it's going to be, oh my goodness. This is really tricky. If I name this, okay, so this is C and then this is C. So that means that B is here and B is here. And then A is here and A is here. So basically it's going to be 90 squared equals 400 squared plus 450 squared, right? Is that what it is? Minus 2 times 400 times 450 times the cosine of c. So that means that we have, so 90 squared is 8100 equals, and it's going to be 400 squared plus 450 squared which is 362,500 minus, so it's going to be 2 times 400 times 450 minus 360,000 cosine of c. So then it's going to be if we add 360,000 cosine of c here on both sides, it's going to be 8100 plus 360,000 cosine of c is equal to 362,500. So then we're going to say minus 8,100 on both sides. So then we have 362,500 minus 8,100. Not 81,000. I don't know if I said 81,000, but 8,100 on both sides. It's going to be 354,400 equals 360,000 cosine of c. So then it's 354,400 over 360,000. That's 443 over 450 equals cosine of c. So that means that cosine inverse, hold on, cosine inverse of 443 over 450 in degrees will be approximately, so c is approximately 10.12 degrees. So 10 degrees? I don't know. Yeah, oh my goodness. That's a weird one. Okay, so which of the following conditional statements would allow us to prove that AB is congruent to line segment AC? Well, okay, AB is congruent to AC. I think that's because I think it's both of them. Oh shit. Oh my goodness. It's not. So, yeah, it would be either statement. Sorry, guys. It would be either statement. That's, AC is congruent to, so basically, this one, so you don't really have to say that BC is congruent to BD. Or, I'm sorry, CD is congruent to BD. This one can be without the statement here. So I believe either one is correct. We can say that angle C is congruent to angle B, or we can say that CD is congruent to BD. Sorry about that, guys. It's very frustrating. So if I'm forgive me if I cursed. So it says draw a line of reflection that reflects ABC to A prime B prime C prime, triangle A prime B prime C prime. So this one, I believe, and so if I go 1, 2, 3, 4. So really, it's a little bit, this one's a little bit tricky because I'm really not 100% sure. So it goes 1, 2, 3. Okay, I see. 1, 1, 2, 3, 4. So it'll go up 2 units. So basically it's gonna go 1, 2, 3, and then 1, 2, 3, 4. So to find the, I believe I know how to do this. This one, it's saying to draw a line of reflection. So we have to find a midpoint from B to B prime. So basically what it's asking us to do is this. And, oh my goodness, let me try this again, hold on. So it's asking us to do something like this. So this is 2, -3, and this is 6, -1, right? So basically the line of reflection would be the midpoint of those two. Like the line would have to be in that midpoint. And also, so we have to do it for 2 points. Looks like this one. So let me see, hold on. Let me try this again. Okay, this is better. So basically we have to find the midpoint between these two lines, or these 2 points and then these 2 points. So the line, so basically B is 2, -3, and B prime would be 6, -1, I believe. So it'd be, so to find the midpoint, you just have to do x1 plus x2 over 2, comma y1 plus y2 over 2. So it'd be 2 plus 6 over 2, because this is x1, this is y1, this is x2, this is y2, and then it'd be comma, and then it would be -3 plus -1 over 2. So then it'd be, so the midpoint between those two would be 8 over 2, comma -4 over 2, which would be 4, comma -2. So it'd be like right here. So you see how it kind of goes like this, and these two distances are the same, so that it would be right here. And now the second point, we can use A and A prime. So A is 3, 2, A prime is 6, or I'm sorry, 5, 6. So if we do the midpoint between those two, it'd be 3 plus 5 over 2, comma 2 plus 6 over 2. So then it'd be, because this is x1, y1, this is x2, y2, so then we would have 8 over 2, comma 8 over 2, which is really just 4, comma 4. So this, so it'd be, hold on. Four, comma 4. Three, 2, so, oh, I'm sorry, negative 3, 2. Negative 3, 2, and 5, 6. My bad. It'd be, so, my bad. I did that wrong. Give me 1 second, guys. I'm just looking really quick. Okay, yeah. Okay, yeah. So it'd be negative 3. So negative 3 plus 5 over 2, comma 2 plus 6 over 2. So then it would be 2 over 2, comma 8 over 2, which is 1, comma 4. So then it would be like right here. So that would be the midline of those 2 points. So the 2 points that the midline satisfies would be the following. And let me close some of these because I feel like I already used them. So it'd be 1, comma 4, 1, comma 4, and then it would be it would be 4, negative 2, right? Okay. Oh my goodness. Oh my, this one I do not know. This one I don't know. I really don't know this one. It says, what is the weight of the air? I feel like this is like volume, but I don't know. It's kind of weird. Because it's a hot air balloon, so then it's like, I'm not sure about this one. I'm really not sure about this one. Okay, side congruency. Oh, okay. That's gonna be ECG, or, so this one's gonna be CEG, I think. Wait, is it? Hold on. Or would it be, I think it's going to be F. I think it's this one. Oh, this is really tricky. Hold on, guys. Give me a second. I'll be right back. Okay, sorry about that, everyone. Give me a second. So, oh, this one's a little tricky. I'm not 100% sure on this one. So, let's see here. Give me 1 second. So, give me 1 second. Okay, so, oh my goodness, this one's a little tricky. I'm really not sure about this one. Congruence of 256. Yeah, I don't know this one. This one's a little bit tricky. Okay, it says which of the following are magnitudes for rotational symmetry of the rectangle below the marked point? Below about the marked point. 180? Oh gosh. This is a little tricky. Okay, so it says find the area of the square units, or find the area in square units of ABC plotted below. Okay, hold on. Let me do this one. This one? Okay. This one is going to be so the distance, and I think it was saying, what was it saying, ABC, right? It was saying ABC. Triangle ABC, right? So we have -6, -2, 2, -8, -6, -2, right? Or I'm sorry, not -6, -2. -4, -6. That's what it was. So we need to find, and it's saying they want to find the area of this triangle. So basically this triangle. Now, to find the area, I believe that the line, that so we have to first find the midpoint. So in order to find the height, we have to find the midpoint of CD. So find the midpoint of CD. So that's going to be, so again, the midpoint is x1 plus x2 over 2, comma y1 plus y2 over 2. So then this would be, so let this be x1, y1, let this be x2, y2. So to find the height of this, or actually the midpoint of this triangle, we would do, hold on. Okay, give me a second, guys. I think I'm gonna have to stop here because I have something to do. I will continue next time on this, but I feel like we got a lot done. Let me go ahead and just, I'm gonna have to end it here, guys. I'm sorry. We did do a lot though. We did a lot. I will continue this tomorrow or later. But hopefully this did help a lot. If you're kind of still trying to figure out, or you know, if you still need help on geometry, please let me know down below. I've been streaming for like 4 hours, which, I mean, that's only because I did the getting ready for geometry and also doing as much of geometry as I could. But I'm gonna have to stop it here, guys. If anybody has any questions and you watched most of this stream, let me know. Like I said, if anybody has any questions, yeah, let me know. And whoever did watch, thank you so much for watching. If whoever is watching, thank you so much for watching. I doubt that anybody watched all the way through, but yeah, this course is, like I said from the very beginning, this course is really hard. It's not, it takes some patience, and some of the questions, like I said, I'm not perfect at geometry. Hopefully this gave you a little taste of the things that I can do versus the things that I cannot do. But yeah, with that being said, guys, thank you so much for watching, and I will post more shorts for geometry and also for algebra and calculus and all those other ones very soon. So please like, comment, and or subscribe, and I will see you guys next time. Thank you so much, guys, and